In this video, we're going to go through double replacement or double displacement reactions. So the general format of a double replacement or double displacement reaction is you have two compounds. Okay, so neither of those are an element by themselves. Now, when I say a compound, anything that's diatomic, so like oxygen or hydrogen, that wouldn't count as a compound. Okay, it's going to be two elements put together. So, for example, sodium chloride, NaCl. That would be an example of a compound. It's made of sodium and chlorine. So you have two compounds. And what's going to happen is the cation from one compound is going to trade places with the cation from the other compound. So those are going to swap. So you'll end up with a cation from A and an anion from B. So from my A compound and my B compound. So I'll take the cation from A and match it up with the anion from B. I'll take the cation from B and match it up with the anion from A. I know that's a little confusing. We'll do an example in a second. So when we do this, we're basically just switching things around. Same rules apply. We want to make sure that the ratio of ions needed to make the compound neutral. We always put the cation first, and then we balance the reaction. So let's look at an example. As with all of the examples that we've done, we're going to start by looking at charges first. So I have potassium, and then I have CO3, which is my carbonate, and then I have barium, and then I have chlorine. Now notice I wrote cations on my first row, anions on my second row. Potassium's in group 1, it's +1. Carbonate is polyatomic, its charge is -2. Barium is in group 2, its charge is +2. And then chlorine is -1. Now, the cool thing about writing it this way is now I can just draw an X. So potassium's going to go with chlorine, and then barium's going to go with carbonate. So potassium's going to go with chlorine, and then barium will go with carbonate. That's it. So potassium and chlorine are both 1. Barium and carbonate are both 2. So now we can balance this. Two, 1, 1, 2, 1, 1, 1, 1. This one's really easy to balance. I'm just going to put a 2 right here. That goes to the potassium and the chlorine. Balanced. All right, let's look at another one. Okay, so same thing. We're going to start with charges. So I've got iron, I have bromine, I have potassium, and I have sulfate. Okay, iron is in the D block, so I have to look at what it's attached to. Bromine is -1, but there's 3 of them, so that means that iron has to be +3, because -1, -1, -1 is -3, so then this has to be +3 to balance that out. Okay, moving on. Potassium is +1, and then sulfate, SO4, is -2. And let's draw our X. So potassium and bromine will go together. So potassium bromide. Iron and sulfate are going to go together, but this is going to be a little nasty because we have a 3 and a 2. The least common multiple is 6, so I'm going to need 2 irons and then 3 sulfates to balance that out. Let's balance the equation. Okay. Well, we might have to go back and forth on this one a few times. So let's start from the bottom up. So let's get my sulfate to 3. So let's put a 3 here. That 3 goes to the potassium and the sulfate. 3 times 2 makes this a 6. I get my 3 here. I need 6 potassiums on the right side, so let's put a 6 here. That goes to potassium and bromine. And then let's put a 2 here. That goes to iron and bromine. Balanced. All right, I think we have one more on here. So again, let's write out our charges. We have sodium, chlorine, calcium, and phosphate, PO4. Sodium is +1, chlorine -1, calcium +2, and then phosphate, PO4, is -3. Let's draw our X. Okay, so calcium and chlorine. I'm going to need 2 chlorines to balance with my calcium. And then I'm going to need 3 sodiums to balance with my phosphate. All right, let's balance out. We've got sodium, chlorine, calcium, and then phosphate. Okay, so we've got 1, 1, 3, 2. 3, 2, 1, 1. Let's start at the top. We'll just kind of see. Oh, I already see a problem. Yeah, let's go ahead and do this. This will require some back and forth. So let's put a 3 here. That goes to sodium and chlorine. So that gets me 3 here and 3 down here. But we have a problem because chlorine, I've got a 3 and a 2. So I'm going to need to change that to a 6. So let's go back and change this. Okay. So let's get 6 chlorines on the right. So let's put a 3 here. That goes to calcium and chlorine. Okay. And then let's put a 2 here. That goes to sodium and phosphate. And balanced. So that happens sometimes. Don't get discouraged if the first number you try doesn't work out. Sometimes you have to go back and forth. And that's double replacement or double displacement reactions.